This is the chapter 3 probability of the course Quantitative Aptitude and Reasoning. Probability is actually the possibilities or the chances of the occurrence of something in a given random experiment, or the chances of happening of an event in some random experiment. Probability is everywhere. This is occurred in almost in everyday life, and we come across with many situations which involve the concept of probability. All forecasting analysis, predictions, seasons are due to probability. Probability is actually the branch of statistics which deals with chances or happening of events and some repeated experiment. So it's a very useful concept, and almost in all type of competitive examinations and departmental tests, the question about probability are asked. Now some related terms to probability are to be discussed in the subsequent paragraphs. The first one is the random experiment. So when an experiment conducted repeated times under the same conditions and it doesn't give the same results, so that experiment is called a random experiment. Okay, already you learnt in the science subjects. Here also we performed some experiments, but they are actual experiments or scientific experiments, because after the repetition we get the same results in that scientific experiment. But here the situation is different. If we perform the same experiment again and again on something here, so the results are not the same. So that's why these type of experiments are called random experiments. Let's take an example of a coin. If I throw a coin repeatedly, so I will get either a head or a tail again and again. Okay, so when a coin is thrown, it will not fall with a particular face always up. Any of the two faces marked head and tail come up each time. Okay, the next concept is event. So what is event? Event is the outcome of random experiment. For example, if I toss a coin, so the results are either a head or a tail. So actually these are the events for the random experiment of throwing a coin. So the outcome of random experiment are called event. Okay, there are many types of events. Some are simple events, compound events. Okay, so event is said to be simple event if it contains only a single outcome of a random experiment. For example, let's take an example of a die. So if I toss a die, so the chance of getting face mark 5 is a simple event, or chance of getting face 1 is a simple event, or chance of getting face 3 is a simple event. Similarly, again take the example of tossing a dice. If I toss a dice, so the chance of getting any face marked even is a compound event, because it contains more than one outcome. So an event is called a compound event if it contains or corresponds to more than one possible outcome. Okay. Exhaustive events. So all possible outcomes of an event are known as exhaustive events. Okay, so how much possible outcomes if we throw a coin? So there are two possible outcomes, either this will be head or tail. So these all outcomes are known as exhaustive events. When two coins are thrown, the number of exhaustive events is 4, that is 2 into 2, that is head, 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 tail, tail, head, and tail, tail. And when a die is thrown, there are 6 exhaustive events, that is the occurrence of faces marked 1, 2, 3, 4, 5, and 6. Okay. Some events are mutually exclusive events. So two or more events are said to be mutually exclusive events if the happening of any one of them excludes the happening of all the others in a single experiment. For example, in throwing a coin, events H and T are mutually exclusive. Here, if head occurs, so it prevents occurrence of tail, and similarly, if tail occurs, then it prevents the occurrence of head. That's why they are called mutually exclusive events. So mutually exclusive events are actually two or more events, and they are happening not cause the happening of the other. If I take the example of a dice, so if a die is thrown, the occurrence of faces marked 1, 2, 3, 4, 5, and 6 are mutually exclusive because the occurrence of one face prevents the occurrence of the other. Okay, what are equally likely events? So two or more events are said to be equally likely events if the chances of their happening are equal and there is no preference to any one event to the other. Again, if we take the example of a coin, so if a coin is thrown, then there are two chances. Either head will be up or tail will be up. So both have the equal chances. Therefore, these events are called equally likely events. In the case of a die, the coming of faces marked 1, 2, 3, 4, 5, and 6 are also equally likely events. Some are independent events and some are dependent events. So independent events are those events which not affected each other. When happening of one event is not affected by the happening of the other, then these type of events are called independent events. And if happening of one event is affected by the other, then these type of events are called dependent events. For example, if a coin is thrown twice, then the occurrence of the head on the first throw is independent of the occurrence of the head in the second throw. Okay, it's not necessary that in the second throw it will come again head. These are independent. And if the happening of an event is affected by the happening of the other event, then it's said to be dependent event. For example, 5 red balls and 4 black balls are kept in a box. There is a box in which we kept 5 red balls and 4 black balls. Okay, and you have to draw 2 balls out of them successively. Okay, so there are 9 balls and we draw 2 balls, so remaining here are 7 balls. Here the chance of drawing a red or black ball is 5 by 9 and 4 by 9, because there are 5 red balls and total are 9 balls in the box, so the chance of drawing a red ball is 5 by 9. And there are 4 black balls and there are total 9 balls in the box, so the chance of drawing a black ball is 4 by 9. That's why we write 5 by 9 for red ball and 4 by 9 for black ball. Okay, if the ball is not replaced and another ball is drawn, then the chance of drawing a red or black ball is 4 by 8, which is 1 by 2. Okay, the most important concept of the probability is the sample space. So the sample space is actually a set which contains all possible outcomes of a random experiment. So the all events are all possible outcomes, all the results, which we combine them in a single set. So that set is called a sample space. For example, if we throw a coin, the number of events in the sample space is 2, that is only head and tail. and probability of an event can be denoted as P of A and can be defined as, so the formula for finding out the probability of some event is denoted by P of A. Suppose A is an event, so here the event is A is the event if a coin is twice once. So its formula is number of favorable outcomes, which denoted by N of A, and number of events in sample space, which is S. Okay, so this formula will be used in the future examples, in the further coming examples, to solve out the probability problems. So if P of A is equal to N of A or N of S, where N of A is number of favorable events and N of S is number of events in sample space. Okay, in the first example, two coins are tossed. What is the probability that at least one head occurs, at least one tail occurs? So now two coins are tossed. So number of sample space or number of events in the sample space are 4. That is tail, head, tail, and tail, head. Now probability occurrence of at least one head. So the number of events in a sample space are 4, and number of at least head is head occurs in this one, and this one also in this one. So the probability is 3 by 4. And now in the second, the probability of occurrence of at least one tail. So tail in this one, in this one, and in this one, and total are 4. So the probability is 3 by 4. Okay, remember one thing, probability is always in between 0 and 1. It's not more than 1 and less than 0. In example 2, a positive number is selected at random and is divided by 6. What is the probability that the remainder is 1 and in the second chance not 1? Okay, if a positive number selected at random is divided by 6, the remainder will be either 0 or 1 or 2 or 3 or 4 or 5. Okay, so the number of events in the sample space is 6. N of S is 6. Now the probability of the event A is equal to N of A over N of S, where N of A is 1, because the probability that the remainder in the case 1 is 1, and N of S is equal to 6. So the probability of A is equal to 1 over 6. Okay, and the second example, in the second part, if the remainder is not 1, the probability of B is equal to N of B over N of S, because we have 6 chances, 0, 1, 2, 3, 4 and 5. So if 1 is not the remainder, then this remainder will either be 0 or 2 or 3 or 4 or 5. So N of A is equal to 5. The favorable outcomes are 5. So the probability of not 1 is 5 over 6. Okay. Okay, if an event is represented by A, then the event not A is represented by A dash or A bar or A complement, and is known as complement of A. This is known as complement of A. And the probability of A and probability of A complement always equal to 1, or probability of A is equal to 1 minus probability of A complement. And probability of an event, as I already told, that it is in between 0 and 1. So this is all about the probability, and I think you learned the concepts related to probability in a detailed manner. There are some upcoming examples. You have to go through these examples and solve by yourself, and not the complicated process. It's just the presence of mind. Okay, so please revise these concepts and try these examples, and if you not know how to solve these problems, please ask in the comment box. I will provide answers in a detail. Thanks for watching this video. Please share it with your colleagues. Thanks a lot.